In this video, I'm going to show how to do iterated calculations and show some of the issues that can arise when such iterated calculations are done. As usual, I start in the MATLAB main window, and I'm going to define the variable x equals 10 in the command window. An iterated calculation is one in which I successively use previously generated values to generate a new value. And I can, in MATLAB or any other programming language, overwrite the original value of a variable with a new value of that variable. So I'm going to define x, a new value of x, based on a previous value of x. So I'm going to take the value of x, I'm going to subtract 9 from that number, and then I'm going to multiply that number by 10. So of course when I do this, the new value of x, which I've defined on the right, has been taken from the old value of x, and of course the answer is 10. Now, this value of x here has been taken, so the right-hand side of this expression is evaluated first. So this expression is evaluated within MATLAB, a result is obtained, and then that value is then given as a new value on the left-hand side as a redefinition of the variable x. So this is a fairly boring example. I can keep calculating a new value of x, and so on, and so on, and so on, simply by pressing the up arrow key. And I can do that many, many times. I always get the same answer, which is great. Let's define a different value. So I'm going to define x equals 1 this time. So this is my new starting value. And I'm going to do the following expression, x minus 0.9, and now I'm going to divide that by 0.1. So to all intents and purposes, this expression looks very similar to the last one. So when I calculate it, now things look slightly different in that a floating point number has been returned. So even though the original value of x up here was defined as an integer, in this expression on the right-hand side, when I've subtracted 0.9, this part of the expression has been converted into floating point format, and when I divide it by 0.1, it's still floating point format. So the result of this right-hand side is in floating point format and is given to the left-hand side as a floating point variable with the value 1. I can recalculate this expression, do it again, there it is. And I'm going to do it again, and everything looks fine. And keep doing it. Oh, something's gone wrong. So even though the answer to the expression, this calculation of 1.000 minus 0.9 divided by 0.1 is always 1.000, at some point the calculation stops working. And each successive calculation is getting worse and worse. Obviously once this value 0.9998 is returned, then the answer gets progressively worse and worse until eventually it means nothing at all. And you can see it's blowing up there. So clearly something very badly has gone wrong, apparently, at this point here. But why did it go wrong there and not before? I was able to calculate 9 or 10 iterations of this calculation before there was apparently a problem. Well, let's look at that a bit more closely. What I mean by that is let's look at all the significant digits which have been calculated, and I can do that by using format long to display everything. So I'm going to redefine x equals 1. I'm going to put a 0.0 on the end just for the original value to be generated, and x equals 1. I'm now going to replay that calculation again, and I've generated a floating point number which has got around about 15 digits of precision in it. Now when I do this calculation again, you will see something has happened. What's going on? Well, the reason we didn't see 1.0, sorry, we didn't see 0.999 when we did the same procedure before, but we only showed a smaller number of significant digits, is that because we were only displaying a limited number of significant digits, MATLAB was taking this number and was rounding it up to 1.000. So it wasn't apparent to us that actually, even at the very first iteration, the calculation was yielded a very slightly different value than this proper value of 1.000. Let's do that calculation one more time. And now you can see that each iteration I'm losing a little bit of precision, around about one significant figure per calculation. Which implies, of course, that if I do around about 10 of these, then I'll have lost around 10 significant digits of precision. And of course on the 11th iteration, or thereabouts, if I had format short, in other words I was only displaying 4 significant figures, I would start to see that digit appearing when I rounded the number to around 4 significant digits. And of course from there on you can see that the precision gets worse and worse. But why is this happening? It's because of the way in which numbers are stored inside any computer. Actually, when this first calculation has been done here, MATLAB has stored the result of this expression, which is where I'm dividing one floating point number by another floating point number. It stored it in a 64-bit double precision number, except that that number is represented in binary. But when it's displayed on the screen, it's displayed in decimal. So that number displayed on the screen has been converted from the internal representation. Now it so happens that when I have the number 0.1, which is the result of this calculation, that number 0.1 cannot be represented with a finite number of binary digits. So internally, MATLAB has truncated that representation of the number 0.1, which is therefore an approximation to the true number 0.1. So even though when it's being converted for display to decimal format, you can see that it's displayed apparently to complete accuracy, but actually it hasn't been. So if I were to define the number here, y equals 0.1, whilst it is being displayed to 16 digits of precision, internally it cannot be stored accurately. So if I were to do 0.1 divided by 0.1, that's something a little bit different, isn't it? You can see that MATLAB is in certain circumstances able to take exact values and process them somehow. So it's able to recognize that 0.1 and 0.1 are computable, they're equivalent to each other, and it can give me an exact integer value. But that's not the case if I calculate the expression 1 minus 0.9 and then divide that by 0.1. If I keep doing that, as I was doing above, let's say if I take that result and I do answer minus 0.1 and divide that by 0.1, sorry, I should have made that answer minus 0.1. I'll do that again. I'll do 1 minus 0.9 divided by 0.1, and if I now calculate answer, sorry, minus 0.9 and divide that by 0.1, then it's different. It's slightly different from this value. And that's because this value 0.1 here is slightly different from this value here. So that's one of the problems you can get when you do any floating point calculation in a programming language. And a good question to ask is this true in any programming language? Well, it's true in pretty much all programming languages except those that do algebraic calculations, programming languages like Mathematica, for example. So here's one I made earlier. Here's Microsoft Excel, and I'm going to put the value 1 in the first row, and I'm going to take that value in the first cell, click on it, sorry, do a formula, equals the value in the first cell. I'm going to subtract 0.9 as I did in MATLAB, and I'm going to put some brackets around that. There we go. And I'm going to divide that by 0.1, and I get the number 1. And I'm now going to copy that formula, so I'm going to drag down and as those cells are filled in, they will automatically fill in the formula above them, and you can see the same thing happening again. So this cell is taking the result in this cell and applying the same formula to it, and so on. So I'm now iterating that calculation step by step, and I see exactly the same problem I had in MATLAB, which was that because I cannot represent 0.1 as a finite set of numbers in binary, then at some point when I do this calculation, I lose 1 digit of precision each calculation, and eventually that becomes catastrophically wrong. So this is something which is a general problem in all numerical calculations, and you should watch out for it. But as you can see, sometimes it won't happen, as we saw here. Where was that? When I divided 0.1 by 0.1, it doesn't necessarily happen. So it's something to be careful of.